In grade 11, there are 4 different types of functions that we learn about: the straight line, the hyperbola, the parabola, and the exponential graph. And today we are specifically going to be focusing on the parabola. So it's important to note that whenever we have an x to the power of 2, we are dealing with a parabolic function. And why is that? That's because we'll have 2 answers for x if we were to solve this. And as you can see, we generally have 2 x-intercepts. And so that is one of our top identifiers. And then the parabola is one of those graphs that has no asymptotes, but it does have an axis of symmetry. So let's have a look at this in a little bit more detail. So as I've said before, whenever we deal with functions, it's so important to be able to have them in the standard form. To just be able to say this is such a graph. So for example, this is a parabola, and a parabola's equation in standard form looks like this. So as we just saw on the previous slide, y is equal to ax squared plus bx plus c. But if you have a look at it, we've actually got 1, 2, 3 unknowns in this equation. And so when we are asked to determine the equation of the parabola, it's actually helpful to have this standard form in different ways. So let's look at 2 that come up often. And here they are. So y is equal to ax plus p plus q, or x plus p squared plus q. Or y is equal to a x minus x1, x minus x2. So those are the 2 forms that we're going to look at. This first one is when we are given the turning point. So we're going to look at the turning point in a minute or two. Okay, and this one here is when we are given 2 x-intercepts. Okay, so those are the 2 types of equations we can use. If they say to us, determine the equation, and we can see it's a parabola, then we need to look at the information we've been given. If we've got a turning point, we'll use this formula, where the turning point is going to be minus p and q, or we're going to use the formula with the x-intercepts, and we'll sub those in for x1 and x2. Okay, like with most functions, to get our intercepts, we have 2 steps. So either we want an x-intercept, and then we let y equal 0, or we want a y-intercept, and we let x equal 0. So that has remained unchanged. The parabola also has what is known as an axis of symmetry. So if you can picture a parabolic function, let's say we've got our axes here, there's our parabola. Then what an axis of symmetry is a line that we can actually draw, which means if we folded this graph, so if we folded the 2 halves onto each other, they would touch. So they mirror image of each other. Okay. And the axis of symmetry has an equation. It's an x line because it just goes through the x-axis, and it's x is equal to minus b over 2a. So if you've got this standard form of the equation, then you can take the b value, minus b, over 2a. Okay, and just worth noting that if you multiply out the turning point form, or this intercept form, it will take you to this standard form. So x equals minus b over 2a is something that you can always use. Okay, and then here at the point, at the specific turning point, on the axis of symmetry, we've got an x and a y coordinate, where the graph changes. In this little sketch that I've drawn, it was decreasing, and now it's going to be increasing. So the turning point signifies that change. Okay, and there are 2 ways that we can work out the turning point. Either we can use this axis of symmetry approach, so we can say, well, we know that x is equal to minus b over 2a, and then to get the y coordinate, we can simply say, well, let's substitute in that x coordinate to our equation. Okay, or if the equation is in turning point form, or even if we want it to be in turning point form, we can actually do that by completing the square. But if we are given turning point form, then we can simply read it from that equation. So we can take negative p value and the q value there for our turning point. Okay, how do domain and range work? Okay, well, we've got 2 types of parabolas. It's worth noting that this a value here actually tells us the shape. Okay, so the shape of a parabola. Now, a parabola is going to go on infinitely in the x negative direction and infinitely in the x positive direction. So domain is easy enough to just say x is an element of the real numbers. Range is going to be slightly different. So if A is positive, let's quickly have a look at that. If A is positive, then we've got what we call, very unmathematically, a smiling parabola. Okay, and that means our turning point here is the minimum. Okay, and remember this turning point is minus P and Q once we figure it out. Okay, so then I can say, if that's the case, then I can say, well, Y is an element, and then we start at the turning point. Remember, we always go from the smallest to the biggest. So the turning point is Y value, Q, all the way up to infinity. Okay, if we have A is negative, so in other words, a sad parabola, the mathematical name for this is actually a maximum value parabola because the turning point is the maximum there. Okay, so there again, we know that the turning point will have the coordinates minus P and Q. So in that case, Q is the maximum Y value. So then we'll say Y is an element, and we'll start with the smallest minus infinity all the way up to Q. So two different approaches to range, and basically if you look at your function, you'll be able to figure that out. Remember to list it from smallest to biggest. Range wants the Y values, that's why we looked at the Y coordinates here. Domain wants the X coordinates, and this is okay. It's true for all values of X. Let's have a look at an example. So sketch the graph of f of x equal to minus x squared plus 6x minus 5. Okay, so what I like to do is just look at my function and identify some things. I can straight away see it's a parabola because x is squared. And the other thing that I can tell from this format is that it's going to be a maximum value parabola because a is negative. Okay, if this were in turning point form, I would probably be able to also tell the turning point. But in this instance, we've got quite a bit of working out to do, which is totally fine, because as long as our theory is intact, we'll be okay. So we know the shape. The shape is what we call a maximum value parabola. Okay. Then we know how to get intercepts. X-intercept, we let y equal 0. So let's do that. Remember that f of x is the same as y. So 0 equals minus x squared plus 6x minus 5. Okay, and then to make that easier to solve, let's divide everything by minus. So 0 equals x squared minus 6x plus 5. And now we can factorize. It's just much easier to factorize when your squared term is positive. So x times x gives us x squared. 5 times 1 gives us 5. And in order to make that minus 6, we'll have to say minus 5 minus 1. And then we do the final check. Minus times a minus is a plus. And 5 times 1 is 5. So that's all good. Okay, now we can just solve it. So either x is equal to 5 or x is equal to positive 1. So we've got 2 points so far on our axes here. X is equal to 5 or x is equal to 1. Okay, and we need to label all of these things if we'd like to get our marks. Next up, we want to work out a y-intercept. So to get a y-intercept, we let x equal 0. Okay, and in this case, have a look at the equation. Y is equal to 0, 0, because that's just going to go away. So it's actually very easy to see in this format. We can straight away see that y is equal to minus 5. So now, on my parabola, I can plot a minus 5. Next up, we want the axis of symmetry. Okay, axis of symmetry. We're going to say x is equal to minus b over 2 times a. So let's substitute. The b value is 6. So minus 6 over 2 times the a value is minus 1. And that gives us a positive 3. Now, if you look at the x-intercepts, it actually makes perfect sense that that would be our axis of symmetry because 3 is exactly in the middle of 1 and 5. Now, I've drawn that axis of symmetry in there, but it is actually not necessary. You don't have to do that. It's not like an asymptote that needs to be drawn, but it's helpful for me because I'm going to need to sketch this graph, and it really does help me to be able to say, okay, where should my mirror image start and end? Okay, then I want the turning point as my last thing that I plot. So turning point, this equation is not in turning point form. So I can't just read it from the equation, but I can work it out. Because I've got the x-intercept already, or the x-coordinate, sorry, of this turning point, I can then say, okay, well, I can get the y value by saying, what is the function equal to when x is equal to 3? So it's going to be minus 3 squared plus 6 times 3 minus 5. And then if we work that out, we get an answer of 4. So now I've got another point that I can plot, which is this turning point here. And that has the coordinates 3 and 4. Okay, so all the way I've been plotting, and now I am ready to draw this function. So there it is, through the y-intercepts, the x-intercepts, the turning points. There we go, and the last thing left for us to do is to just name it and say this is the graph of f. Okay, and then just a quick recap, how do we draw quadratic functions, or how do we draw parabolas? We have a look at the shape, then we determine x-intercepts, y-intercepts, the axis of symmetry, and the turning point. So before we can draw it, we have got 1, 2, 3, 4, 5 steps that we need to do. Okay, it's good to know how to draw it. It's also good to know how to determine the equation if it is already drawn for us. So this here is a parabola. I can see it's a maximum value parabola, or just a sad face. Our a value is negative, but they are asking me here to determine the equation of the function below. Okay, so I have a look at the information I'm given. The fact that they've drawn this dotted line here means that this is my turning point, minus 1 and 6. Okay, and then there's another point here. It's on the y-axis, so what I'm going to do for myself is just say, well, that's a y-intercept, which is where x equals 0. So I'm just going to rewrite it there as 0 and 2. Okay, so I know that the equation of a parabola should be y is equal to ax squared plus bx plus c. But in order for me to get there, I need to use one of my stepping stones. Okay, so remember we've got two potentials that we could use. Here they are. So either I have the turning point or I have two intercepts. Now looking at it, there we go. I've got the turning point. If I have that, that's always first prize for me. I don't have two x-intercepts, so I couldn't even use that one if I wanted to. So looking at this turning point, what I know is that it represents the coordinates minus p and q. So just be careful of that sign when you substitute in there, because it's actually going to be a positive one that you need to substitute, because they just want the p value, not the minus p value. Okay, that's one spot to be vigilant when you're substituting in. Okay, so the first thing we do is we sub in the turning point. Okay, so we're going to take our equation, y is equal to a x plus 1 squared plus 6. Okay, step 1, sub in the turning point. Step 2, sub in one other point. Okay, so the other point that we've got is that one, 0 and 2. So in the place of y, I can write 2. In the place of x, I can write 0. And now I just need to solve. Okay, 2 is equal to 0 plus 1 is 1, and then 1 times 1 is 1. So that's just going to be 1a, and we can actually just write a plus 6. And then let's move this over so we get a on its own, and that shows us that a is actually equal to minus 4. Okay, and once we've done that, we sub the a value back into step 1. Okay, and that will be our final answer. So let's have a look. Then step 1 said y is equal to a, x plus 1 squared plus 6. So now what we'll do is we'll say y is equal to, instead of a, minus 4, x plus 1 squared plus 6. Okay, so this is considered determining the equation here, and then it just comes back to reading the question. Okay, they will often tell you determine the equation in this form or determine the equation in this form. If they don't specify, you could probably stop here, but it's just best to be safe and to multiply this whole thing out so that you have it in the standard form. Okay, so let's quickly do that over here. We're going to take our equation. We're going to say y is equal to minus 4, and then we've got this x plus 1 squared brackets plus 6. Okay, so minus 4, we're going to get to that later. Remember the shortcut for squaring. Square the first, then you multiply the two terms, so x times 1, and you double it, so plus 2x plus 1. Okay, now let's multiply that minus 4 in there. Minus 4x squared minus 8x minus 4 plus 6. And finally, we can just collect our like terms. Plus 2. And good news, that plus 2 is indicative of that y-intercept there. So we've definitely done the right thing. Okay, another thing that was good news for me was the minute I saw an a value was negative. That was true because it is a sad face parabola. Okay, so the steps here, if we need to determine the equation, step 1, substitute the turning point. Step 2, substitute one other point. And then finally, step 3, take your answer in step 2 and go and pop it into the equation in step 1. Let's take a look at one last example. So determine the equation of the function below. I can see that it's parabola. That means my brain immediately goes y equals ax squared plus bx plus c. And then I ask myself, what information do I have to work with? Okay, I've got a minus 2 here, which is an x-intercept. So let's rewrite that as minus 2 and 0. I've got another x-intercept here at the origin. So even though they didn't label it, I can see 0 and 0. And then I've got this random other point here, 1 and 5, which is going to come in handy. Okay, so I have a look. Do I have a turning point? No. And so I'm going to have to use that x-intercept formula, which is completely fine. So y is equal to a x minus x1, x minus x2. Okay, that's the formula there. So step 1, we sub in the x-intercepts. Okay, so y is equal to a x minus minus 2 and x minus 0. Okay, and then step 2, this is very similar. In the past one, we subbed in the turning point. Now we're subbing in our intercepts. Okay, as long as you start with the right equation, you'll be okay. The next thing is we sub in another point. Another point. And in this case, we've got the point 1 and 5. So in the place of y, a 5, 1 plus 2, and 1 minus 0. Okay, and then we're just going to work things out. So we've got 5 is equal to a times, let's see, 1 plus 2 is 3. 3 times 1 is just 3. So that's actually going to be 3a. And then let's divide both sides by 3. And so we discover that a is equal to 5 over 3. And then step 3 was to then sub that a value back into step 1. Okay, so we're going to take that a value there and we're going to pop it in to its spot there of the equation. Okay, so we've got y is equal to, instead of a now, 5 over 3 multiplied by x plus 2 multiplied by x minus 0, which I'm just going to call x. Okay, so there we go. 3 values again, 3 steps again to get us to this equation. Okay, this I definitely wouldn't leave my answer here. I would do some multiplying out. Okay, so what I would do next is I would take that equation. I would multiply this and this just because it's going to make my algebra a bit easier. So I'm going to say y is equal to 5 over 3x multiplied by x plus 2. Okay, and then we've got 5 over 3x squared plus 10 over 3x as our equation there. Not the nicest. I know whenever you guys see fractions you get stressed, but that is a perfectly acceptable answer. And again, you can see there the c value is plus 0, which is true.